You ever drive past one of those huge industrial plants with all the pipes and towers and just wonder, how does that whole thing not just go boom? Well, it's definitely not luck. There's an entire invisible architecture of safety built into the very bones of that place. And today, we're going to pull back the curtain on that hidden world.
This right here is the single most important question in industrial safety. We always hear about the disasters when they happen, right? But the real magic, the real genius, is in stopping them before they even have a chance to begin. So how on earth do you do that?
The answer isn't some single brilliant invention. No, it's a super detailed, meticulous process of asking what if over and over and over again about every single bolt, pipe, and building. Safety engineers have these incredibly detailed checklists that are designed to poke and prod at every potential weakness imaginable.
And this whole process actually has a name. It's called facility siting. And it really is a science, the science of arranging an entire industrial site to be as safe as humanly possible, long before anyone even thinks about breaking ground.
Think about that for a second. With facility siting, literally nothing is left to chance. Where you put the control room, the path a little service road takes, the exact position of a giant storage tank, every single choice is a deliberate calculation. It's all designed to minimize risk from day one.
So, where do the engineers even start with something so massive? Well, they have to start with the big picture. They don't just look at one piece of equipment by itself. They look at the entire plant as this one giant interconnected system, where one little thing going wrong could have a massive ripple effect everywhere else.
And the scope of this is it's staggering. We're not just talking about the big, obvious process units. These planners, they evaluate everything. The control rooms where people work, the massive tank farms, the pipe bridges running overhead, even the maintenance shops, the roads, and the sewers running underneath it all. Every single piece is part of the safety puzzle.
Okay, let's zoom way in to see this in action. Let's take one tangible detail. If you've got a huge tank holding some kind of liquid, you absolutely need a containment barrier around it. It's often called a dike. It's there to catch any spills. Seems simple enough, right?
But wait a minute. This is where that engineering precision really kicks in. You can't just eyeball it. Does it need to be, half the size of the tank? The exact same size? Because if you get this wrong, that barrier is totally useless. So, what's the rule? The rule, according to the standards, is 110%. That little extra 10% isn't random, it's a critical safety margin. It's a buffer that accounts for the real world, things like heavy rainwater getting into the containment area. It ensures the barrier will actually do its job even when conditions aren't perfect. Of course, it's not just about liquids you can see. Planners have to think about invisible hazards too, like vapors. And it comes down to basic physics. Some chemicals are lighter than air, so they'll rise up and could get trapped under things like building canopies. But others are heavier than air. They'll sink, pooling silently and invisibly in low spots like trenches or drains. The layout of the plant has to account for both of these dangerous scenarios.
Okay, so let's shift gears from the equipment to the people. Because the most important asset at any facility is, of course, the workforce. A huge part of facility siting is about designing the buildings, especially places like control rooms, to basically function as a safe haven during an emergency. So how do you turn a normal building into a fortress? Well, first, you've got to control the air. You need the ability to seal every fresh air intake from the inside to keep toxic stuff out. Next, you tackle the weakest points, the windows. They have to be reinforced or even removed so they can withstand the pressure from a blast wave. Then you plan the escape route. You make sure there's at least one exit that points away from the danger. And finally, you have to look up and make sure people are protected from anything that could collapse on top of them. And it's truly incredible how deep the details go. These safety plans write down things that you might just think are common sense. For example, all exit doors have to open outward. Why? So a panicked group of people can just push their way out instead of getting jammed up. And corridors must, at all times, be kept completely clear, because in an emergency, a box of supplies left in the hallway isn't just clutter, it's a deadly obstacle.
But here's the thing. This kind of safety planning doesn't just stop at the property line. A modern industrial facility is part of a larger community, and its responsibility absolutely extends to its neighbors. This is all about being a good, responsible neighbor. It means having reliable systems to warn the community if there's a release, and just as important, making sure people know what those alarms actually mean. It also means protecting your own workers from something that might happen at the plant next door. And it means simple things, like locating your most hazardous materials far away from public roads. It's a two-way street of safety.
When you really boil it all down, true safety isn't a department you call or a single piece of equipment you buy. It's the grand total. It's the cumulative result of thousands and thousands of small, smart, deliberate, and interlocking decisions that were all made before a single piece of that facility was ever built.
Every single detail we have talked about, that 110% rule for the dike, the direction a door swings, the special seal on a window, the location of a tank, each one of those choices is another layer in this deep, complex, and resilient system of protection.
And that really brings us to the final thought here. Now that you know about this invisible architecture of industrial safety, you might start seeing it everywhere. From the way our highways are designed to the layout of our cities, what other invisible safety systems are quietly working all around you every single day to keep you safe?